So, good day to all of you. My name is Julian Manalang, and today I will be teaching you about coding theory. Okay, so first of all, I would like to apologize for my raspy voice because I'm quite sick. But let's get started. So, I'm just going to explain. We're going to go over these three main topics, okay? ASCII translation, Hamming distance, and error detection and correction. Um, all of these topics were already explained in the website, and I am assuming that you have already gone through those materials. But even if you haven't gone through all of those materials, honestly, these topics are really easy. Most of it are just common sense, so there's nothing really to worry about. Okay, it's gonna be fine. So problem one, translate the following code and respond. So we have 6 codes, but as you can notice, okay, these two are the same, and then these, okay, the middle ones, they're the same, and the last ones are the same, so they're just repeated. Okay, so the way you read this is, okay, from this one, this one, this one, and then this one, this one, this one. Okay, so there we go. So I'm just going to recall it. Okay, so this is the same as this, as you can see, right? This is the same as this, and this is the same as this. So I'm just gonna remove that so that it doesn't look cluttered. Where is the... there we go, there we go, there we go. So now the steps for this is really simple. We're just going to find this in the table, and as you can see, I've already highlighted the important values so that we don't have to skim and scan all of these, because it's going to take a decent amount of time. So we're just going to save ourselves some minutes of our lives, and we're just gonna go. So E is 0, 100, 0, 1, 0, which is this one. So this is E, and as I've said before, this is also E. So H, which is 0, 100, 1000, 0, 100, 1000. Okay, H, and as I've said, H. And the remaining value is P, which is going to take the remaining spots. That's it. That's all there is to it. But the problem earlier said to respond. So hep hep, the response is hooray, right? Hep hep hooray. Okay, so we're done. It's that easy. So this one, problem 2, it's also very easy. Find the Hamming distance between these two codes. To make our lives easier, we're just going to move this to the bottom. Okay, you're gonna see why. Because as you can see, they are perfectly aligned. Now all we have to do is to compare each place value with one another. So 0, 0, are they the same or not? Yes, they are. 1, 1, yes, they are. Are these the same? Yes, they are. But look at this. Okay, 1 and 0, they're not the same. So X, 0, 1, not the same. 0, 0, the same, and not the same. And all we have to do is to count the number of X's, which is 3. And that's it. That's the minimum distance. I mean the Hamming distance. Hamming distance. That's it. It's that easy. And now problem 3 is basically almost the same as the second problem. Okay, but as I've mentioned in the what I call this, in the website, it's that the minimum distance is the smallest value. Okay, so basically what we're going to do is we're going to find the Hamming distance between pairs of the codes. So as you can see, look, Okay, we're going to have two rows. These are the same, these are the same. This is the same as the problem 1 from earlier. So let's just call this A, B, and then C. Okay, so what we're going to do is we're going to shift the bottom. Okay, we're going to place A to here, which would make B go here. Okay, does that make sense? I hope it does. Because I'm just gonna erase this so that it's clear. Erase. So what I've just said is basically this. We are going to, this is A, B, and C. So as I've said, we're going to shift A. So it's going to go here, then B is going to go here, then C. Okay, and then there we have unique pairs, 3 unique pairs. Okay, no one is the same. So let's just erase that again, so we can go and proceed to our calculations. All we have to do in this part is we're just gonna do the same thing essentially. The same. Okay, 1 1 same, 0 0 0 0 same, 1 0 not the same, 0 1 not the same, 0 0 same, not the same. Okay, so this one, this pair is 3. The Hamming distance is 3. So moving on, same, not the same, not the same, not the same, not the same. This one is 4. Okay, this pair right here is 4. Now the next one, not the same, not the same, not the same, and that's it. It's 3. So therefore, the Hamming distance, or should I say the minimum DC is 3. Now, what does this imply? I'm sorry for the poor handwriting. I'm not accustomed to writing with the mouse. But anyway, what does that imply? Detect and correct. How many errors can this code detect and correct? So what we're going to do, we're gonna erase all of these things on the screen. Erase. As I've mentioned earlier in the website, there is an equation, and the equation was this: DC is equals to 2E plus 1, where 2E refers to the amount of errors that the code can... Okay, I'm sorry if you can hear the background. There are dogs outside the house. Okay, I'm not sure if you can hear it, but I apologize for that. But anyway, 2E refers to the amount of errors that the code can detect. Okay, but E alone refers to the errors that the code can correct. Okay, so as you can see, DC is equals to 3. So let's just do some basic algebra. Okay, 2E plus 1. And I'm just going to transpose. So 2E is equals to 2. That means that this code right here can detect 2 errors, but it can only correct 1. And that's it. So as I've said before, it's really not that hard. Okay, it's really not that hard, honestly. So yeah, I hope you guys learned something from this, and once again I apologize for my raspy voice and the dogs outside the house. But anyway, thank you for watching, and I hope you guys go to the next module, which is about cryptography. See you later.